Welcome to the Diagnostic Clinic, everyone. I'm your host, your lead strategist, and today we are going to do a complete teardown of one of the most critical areas in your exams. If you're studying for the Cambridge AS and A-Level Mathematics 9709 syllabus, or frankly, if you're tackling any of the major Cambridge math papers like the 0580, 0606, 4024, 4037, or 4040, you're exactly where you need to be. Today, we are opening up the examiner's playbook and taking a deep, surgical dive into quadratics, specifically solving quadratic equations and inequalities. We're going to operate like lead physicians today. We are going to diagnose the symptoms of a failing answer, figure out exactly where candidates bleed marks, and then we are going to prescribe the absolute cure. We are looking right past the raw numbers to focus on the actual architecture of a perfect, bulletproof answer. So grab your notes, get comfortable, and let's decode this entire system together. So let's start with the big, glaring question. Why is quadratics one of the most consistently misunderstood areas in all of mathematics? Senior examiners report year after year, paper after paper, that students just stumble here. But here is the massive secret. It's almost never the core math that's impossible. It's not that you don't know the quadratic formula. The breakdown happens in how students present their evidence and evaluate their findings. Think about two types of students we see all the time. Let's call them Alex and Sam. Now, Alex is the classic overloader. Alex memorizes every single raw mathematics fact, but when it comes to an exam, Alex just vomits a wall of numbers onto the page with absolutely no analysis, no structure, just chaos. Then you have Sam. Sam is the rusher. Sam races through the paper, completely misses the specific command word requirements, doesn't format the answer correctly, and just prays the final numbers right. Both of these students end up with answers covered in red pen marks, not because they are bad at math, but because of their communication and structure. It's about proving your conceptual understanding to the examiner, rather than just treating it like a sprint to a final number. And this brings us to the ultimate cure for Alex and Sam. The crucial point is this literal examiner alert. Even if your final answer is wrong, method marks can save you. I call this the method over magic approach. Listen, you aren't a magician trying to pull a rabbit out of the hat. You are an architect building a logical bridge for the examiner to walk across. Showing you're working out is your ultimate safety net. Top students structure their mathematics answers almost like a forensic argument. Have you ever heard of the Peel framework? Point, evidence, explanation, link. It's usually for essays, right? Well, watch this overlay. Top math students use Peel too. The point is identifying the correct mathematical principle. The evidence is writing down the correct formula. The explanation is your clear line-by-line working out. And the link is tying your final numerical answer back to the actual context of the question. When you structure your math like that, you are showing the examiner you understand the entire journey, meaning even if you slip at the very end, those method marks are secured. Okay, here is our roadmap for this session. First, we'll look at the quadratics trap. Then, core principles and domains. Next, the standardized processing sequence. After that, we'll hit evaluation and critical analysis, and we'll finish strong with the top 3 examiner warnings. Now, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Seriously, get that done so we can keep building these strategies together. Let's move right into Section 1, the quadratics trap, understanding the true challenge. The true challenge with quadratics isn't just about whether you can factorize a basic expression or plug numbers into the quadratic formula. A calculator can do that. Cambridge wants to know if you can do the heavy lifting. The real test is evaluating evidence and drawing conclusions in totally unfamiliar contexts. You see top students, the ones securing the absolute highest marks, the ones turning those red crosses into green check marks, they don't just blindly calculate. They exhibit a connected conceptual understanding. When Cambridge throws a bizarre, highly specific real-world context at them, like modeling the arc of a bridge or calculating the optimum profit margins for a business using a quadratic curve, they do not panic. Their foundational knowledge transfers seamlessly to these new, unfamiliar problems because they understand the why behind the quadratics, not just the how. They decode the command words flawlessly. Moving on to Section 2, Core Principles and Domains, the Foundation of Marks. If you look closely at the syllabus, it very clearly outlines that the assessment objectives target 3 specific cognitive domains: knowledge and understanding, application, and analysis. Think of this as your mathematics success blueprint. To absolutely ace your exam, your conceptual framework has to draw heavily on systematic analysis and evidence-based reasoning across all 3 of these areas. First, knowledge and understanding. Do you actually know the rules and conditions for a quadratic inequality? Second, application. can you take that rule and apply it to a messy problem without losing your structure? And third, analysis. Can you look at the results you just generated and figure out what they actually mean? The students who hit a wall, like our friend Alex, might have the knowledge part down, but they completely fail at application and analysis because they aren't treating the math as a connected system. And that realization brings us to the formal definition of the method mark strategy. This is the official practice of awarding marks for the analytical process, your methodological framework, and your clear working. It is definitely not solely about the final numerical answer. I really want to hammer this point home for you guys. The mathematical process is the true hero of your exam paper. If you establish the correct quadratic inequality, if you show the examiner exactly how you're solving it, but you make a tiny arithmetic slip at the very end, maybe you drop a negative sign, your method marks are what will protect your grade. The examiner looks at your working and says, okay, the process is flawless, the logic is sound, they just made a calculator error. Boom, you still get the majority of the marks. This is how you guarantee top marks. Let's dive into Section 3, the standardized processing sequence, executing the methodology. Cambridge examiners expect a very specific, step-by-step procedural framework. It's practically a time management matrix for your brain. Step 1, identify the key elements of the question. What is the command word asking you to do? Step 2, apply the relevant principles. Ask yourself, is this an equation or an inequality? That changes everything. Step 3, execute your analysis with crystal clear working. This is where your Peel framework shines. Step 4, verify your results. Do they make logical sense? Step 5, present your answer in the appropriate format. Presentation follows strict conventions, proper headings, correct terminology, and clear annotation. If you skip these steps, you are literally leaving easy marks on the table. Now, right before we get into the really advanced stuff, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's keep going. Which brings us to Section 4, Evaluation and Critical Analysis, Securing Higher Order Marks. I want you to think of your answer as climbing a mountain. At the very base, you have the descriptive level. This is just stating the facts of the quadratic, maybe writing down the formula. It's basic. In the middle, you reach the analytical level, where you are actively processing the math and churning out the intermediate values. But the absolute peak? That is the evaluative level. Higher order assessment objectives demand that you evaluate alternatives, compare approaches, and justify your recommendations. To maximize your marks and reach that 100% mark potential, your answer must progress steadily upward through these 3 levels. You can't just camp at the base and expect an A-star. Now, we are going to run a quick interactive workshop right here. Challenge 1, data scan. Imagine a complex mathematics chart on your screen right now, showing 2 different quadratic models. You have a 60-second mental timer. How do you extract the core trend? Well, tackling comparative analysis requires a dual approach. You must identify similarities, using evidence to link common traits between the graphs, and simultaneously identify differences, using comparative connectives to contrast their behaviors. For example, maybe both curves have a minimum turning point, but they intersect the y-axis at completely different values. By balancing both sides, you were able to draw robust conclusions about their relative importance. This proves to the examiner that you have a deep, balanced understanding of the mathematical models in front of you. Let's move to Challenge 2, Find the Flaw. I want you to think about how you evaluate the quality of your mathematical evidence. It requires rigorously checking 4 specific factors. You need to identify limitations, explicitly state any assumptions made, consider alternative interpretations, and measure their effect on conclusions. Let's say you're given a sample paragraph answering a quadratic word problem about a car's braking distance. Where is the flaw? The flaw usually happens when a student forgets the assumptions. If you are modeling a real-world scenario with a quadratic equation, stating your assumptions, like assuming the road is perfectly flat or air resistance is negligible, proves you understand the boundaries of your own mathematical evidence. The examiner commentary always highlights that top candidates point out these limitations, whereas average candidates just accept the numbers blindly. All right, let's head into Section 5, Top 3 Examiner Warnings, Avoiding Common Pitfalls. I want you to pay very close attention here. There are exactly three massive, recurring mistakes that the principal examiner reports explicitly warn candidates against every single year. These are the brutal traps that cost otherwise brilliant, hard-working students their top grades. Let's break them down. Mistake 1. Confusing cause and effect within quadratic relationships. Don't mix up your independent and dependent variables. Mistake 2. Forgetting to check format and presentation. This is what our student Sam does, rushing through and giving an answer in surd form when the question specifically demanded 3 significant figures. That is throwing marks away. Mistake 3. Providing answers that are not specific to the context given. This is huge. A standard student will calculate the quadratic formula, get an answer like x equals -5 and x equals 10, and just leave them both there. But a top performer? They realize that if the context is about the length of a piece of wood or a measure of time, a negative number is physically impossible. They will explicitly cross out the negative answer and write rejected based on context. Now, challenge 3 is a speed writing test. The next time you practice, give yourself a 30-second timer to write one perfect Peel paragraph explaining why you rejected a root. That is the difference between a good candidate and an outstanding one. So with all of this information, how do you actually remember this complete answering system under the intense pressure of the exam hall? Here is a syllabus recommended memory hack. Create your own mnemonic using the first letters of these key terms. Identify, apply, execute, verify, present. Make up a memorable, funny acronym for IAEVP. Doing this helps you lock in that standardized processing sequence so your brain can automatically deploy it when that exam clock is ticking down and the pressure is on. I want to leave you with this final, crucial question. If method marks are the key to saving your grade, how will you structure your next quadratics answer? Remember, the 3 rules that guarantee top marks: command word decoding, Peel framework application, and your time management matrix. Process always beats just guessing the final number. Keep practicing those past papers, build that logical bridge, and show you're working every single time. Listen, students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, AC Exams, at acexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing right now. Our team responds to every single comment. Like and share this video with a study partner who needs to hear this. AC Exams, your Cambridge success starts here.